I will be teaching you graphing cubic functions, unit 4.1. The first thing you need to know about cubic functions is the parent function. This is the function that everything kind of runs off of and uses as, So, as you can see, the parent function is just the regular f of x is equal to x cubed, and this is what the graph looks like. Next, you'll need to know the cubic transformation forms. This is what all of the transformations run off of. And as you can see, h is the x-coordinate of the axis of symmetry, k is the y-coordinate of the axis of symmetry, and b and a is the slope. Now, to expand on this, if you were to have, or if a or b were to be negative, this is what your graph would look like. And it would be called a translation of the reflection over the y-axis. Just like that. Next, if h were to be changed, you can see here that it says if h were 0, which is the red one, it'd be right in the middle. It'd look just like the parent function. If h was 1, then it would be translated to the right one and it would be moved over. And as you can see, the black one. And if h were to be negative 1, then it would be translated to the left and it would be moved over. If k were to be switched, then it would kind of be the same thing as last time, except instead of moving it left and right, you would move it up and down. There you go. If a were to be 2, which would be the same thing as b being negative, or b being 1/2, then you would see that it would be compressed vertically if it was the a, or it would be horizontally compressed if it was in the b. And as you can see, it's kind of like skinnier, it's narrower. It's skinnier, it's a red line. And then if it were to be the other way around, then it would be a little bit fatter. So you can see there would be vertical compress or horizontal stretch. And then for the end behavior for cubic functions, since it's cubic and the exponent is an odd number, then the lines will be going from end to different sides or different ways. So if it's positive, then it would be coming down and it would be going at the end, it would be going up. And if it was negative, it'd be the other way around. It would be starting from the top and it would be ending at the bottom. Alright, and here for the first example, you see this is kind of simple, but first we're going to name out the transformations. And for this one, the transformations would be, you're reflecting over the y-axis because it's a negative 2 in the a. So, yeah. And then since it's a 2 in the a, you would be vertically stretching it by 2. And then since there's a 1 in the h, which you know it's a 1 in the h because if you look at the transformation formula, it says that this in the middle is x minus h, so you have to flip that one around. So h is equal to 1, which makes it, since h is equal to 1, then it's translated right 1. And then for k is equal to negative 1. And then for that, it's translated down 1. Alright, and an easy way to find the 3 points that you graph off of is to make a little table like this, and you add on each side what you're translating it. So for x, the only thing that we're doing to that is adding 1. And for y, we're multiplying it by negative 2. And since this is outside of the parentheses, then that means that you have to multiply the y. And if it was inside, then you have to multiply by the x. And then over here, all you're doing is subtracting 1. So, and also for the parent function, the 3 points that you use for the parent function are -1, -1, 0, 0, 1, and 1. And all you do is just, like over here, you just add 1 to each side. So this would be 0, 1, 2. And over here, you would multiply it by -2, so that would be a 2, and then you subtract 1, which would be a 1. And then 0 times -2 is 0, minus 1 is -1, and -2 times 1 is -2, minus 1 is -3. And then all you do from here is that you just plug the points in. So the points would be 0, 1, 1, -1, and 2, -3. So 0, 1, 0, 1, 1, -1, 1, -1, and 2, -3. And then since it's a negative in front of the coefficient, it would be coming down from the right and up to the left. So this is how you draw it. And to distinct it from a cubic function compared to the other ones is this little part right here that kind of slows down, and it doesn't keep going at a regular pace. If it was a quadratic function, it would be coming like that, and if it was a linear function, it'd just be a straight line. And for the domain, which is the y, it's all real numbers, and for the range, since no matter where you go, it can hit any number. And then the end behavior, since it's going down over here as x approaches infinity, y approaches -infinity. And as x approaches -infinity, y approaches infinity. Alright, and that is it for the first equation. Alright, for the second equation, it's a little bit more complicated, but it's not that bad. So since there's no negative in front, you're not reflecting it over the y-axis. All you're doing is horizontally compressing it by horizontally compressing it by 1/2, and you have to do that because in the root transformation the transformation formula, it says that it's 1 over b, and since b is 2, you have to put 1 over 2. And then since h is -3, you're translating it left 3. And since k is 4, you're translating it up 4. And we're going to do the same thing that we did last time with the table. So over here, we're going to multiply it by 1/2 because it's inside the parentheses, so you multiply x by 1/2, and you're subtracting 3. And over here, all you're doing is adding 4. And then the same, use the same points to start with. -1, -1, 0, 0, and 1, and 1. So over here, all you're doing is adding 4. So it's 3, 4, 5. And then over here, you're multiplying it by 1/2. So -1 times 1/2 is equal to -0.5. 1/2 times 0 is 0. And then over here, 1 times 1/2 is 0.5. And then over here, you're just subtracting 3, so -3.5, -3, -2.5. Alright, so our points will be -3.5, 3, -3, 4, -2.5, 5. Alright, and then all you're going to do is graph these. So -3.5, alright, -3.5, 3, so there, -3, 4, so up there, and I kind of ran out of room, so the last one is going to be somewhere up here. Okay, since this is positive, it's going to be coming down from the right and then up at the left, just like that. Alright, and then for the domain, for the cubic function, it's always all real numbers for the domain and range. And the end behavior, since it's positive, is x is approaching infinity, y is approaching infinity. So x approaches negative infinity, y approaches negative infinity. Alright, and that is it for the second equation. Then for the last equation, this one's a little bit more difficult. Transformations for it are that you will, since there's a negative in the a, you're going to reflect it over the y-axis. And then since it's in the, or it's outside the parentheses and it's in the a place, you're going to vertically stretch it by 5/2. And since h is equal to 3, you're going to go right 3. And then since k is equal to 1/2, you're going to go up 1/2. Alright, for the chart that we usually do, we will, since all we're doing to the x is adding 3, we're just going to add 3. And then for the y, we're going to multiply it by -5/2, and we're going to add 1/2 to that. Do the same points as we always do. And then for the x, we're just going to add 3, so that's 2, 3, 4. And then for the y, we're just going to multiply by -5/2, which times -1 is just 5/2. This is 0, and that is -5/2. Alright, and then all you're going to do here is add 1/2. So this would be 3, this is 1/2, and this is -2. Alright, and then to graph this, our points would be 2, 3, 3, 1/2, and 4, -2. Alright, so we're just going to plug these points in. 2, 3, 3, 1/2, and 4, -2. Alright, and then since this is negative, it's going to be coming down, or up from the left and down from the right. So start down here, up, and there, just like that. And once again, our domain and our range are always all real numbers. And our end behavior, since it's negative, is as x is approaching infinity, y is approaching negative infinity. As x is approaching negative infinity, y is approaching infinity. Alright, and there you go. That is how you graph cubic functions.